During shearing, wool is sorted or classed into lines of wool based on the breed and ages of the sheep, the colour, length, fibre diameter and other characteristics of the wool. Bales of wool of similar characteristics will be used to create individual lots for market. Each lot will include the farm brand and the numbers and weights of each bale, which form the unique identifiers of the wool. Sampling, weighing and identifying wool bales from each lot is a critical part of wool testing. A grab sample is used to provide prospective buyers a representative sample of the lot to visually appraise the characteristics of the wool. It is also the sample that is used for the measurement of staple length and strength of any lot. Grab sampling requires a machine with a mechanical set of jaws to extract wool from various positions and depths of each bale, so that each portion of wool has an equal chance of being selected. The number of grabs taken from each bale will depend on the number of bales within a lot, with more grabs taken per bale from smaller lots to ensure a representative sample. After grab sampling, the bale is weighed. The weight of each bale is recorded in whole kilograms. Core sampling is then conducted to provide a representative sample to determine the clean weight of the wool using the yield test, as well as providing the material for the fibre diameter and colour tests. The coring and weighing steps are performed within a short time frame to ensure there is no change in moisture in the wool between these two very important stages. For machine sampling, the bales are compressed to half their length and a series of core tubes are used to take a sample from the bale. The position of the core tube is randomized to remove the risk of sampling bias. Every bale in a lot must be sampled, and the number of bales in the lot will determine the number of core samples which are taken from each bale. This sampling procedure ensures a representative core sample is taken and sufficient sample material is provided for the various tests to be performed. Each sample bag contains the core sample taken from each bale in the lot. Included in the bag is the test request form, which sets out the details of the lot being tested, such as brand, bale numbers, bale weights, who performed the sampling, and the types of tests required. Each sample is weighed, allocated a unique test number, and data from the test request form is entered into the computer. Samples are washed in laboratory-sized scour bowls to remove dirt and grease. The scouring process involves a number of cycles and is standardized for water volume and temperature, as well as the type and volume of detergent used. Following scouring, the samples are placed in cans and excess water is extracted. Samples are then dried until no moisture is present in the wool. Once the samples have been washed and dried, they are weighed to determine the amount of clean wool following the washing and drying process. Knowing how much clean wool is present in a parcel of wool is a critical function of wool testing. After washing and drying the wool, there is still some residual material in the sample, which is not wool. To calculate the clean weight of the wool, we need to determine the amount of ash, grease, and vegetable matter left in the sample. Smaller subsamples are taken from the dried samples so that this residual material can be measured. Further samples are also taken for measuring fibre diameter and colour. Wool colour is determined by measuring the amount of red, green and blue light reflected from the clean sample using a spectrophotometer. 4 independent measurements are reported. These are simplified as X, Y and Z respectively. The amount of reflected green light, known as the Y value, is indicative of the brightness of the wool. The higher the Y value, the brighter the wool. Y values in New Zealand wool typically range from 55 to 70 units. The difference between the green and blue values, reported as Y-Z, represent the degree of yellowness in the wool. The higher the Y-Z value, the more yellow the wool. Y-Z values can range from less than 0 units to over 10 units in New Zealand wool, with very white wool having a negative Y-Z value. Fibre diameter is the main determinant of yarn performance and hence the end use of the wool. Fine yarns require fine wool to ensure the yarn is even and doesn't break during processing. The fibre diameter of New Zealand crossbred wool is usually measured by the airflow method. Two independent samples weighing exactly 2.500 grams are placed in the chamber of the airflow meter. A vacuum is applied to the chamber and the amount of air passing through the chamber is measured on a flow meter. 4 independent readings are recorded across the two samples. A set of calibration wools are used to build a series of known results, and a table is developed which has a given flow rate corresponding to the micron of the wool. The sample used for the laser scan doesn't need the vegetable matter removed before measuring, but to measure we use a mini core to present thousands of fibres to the instrument. The laser scan instrument measures the size of the shadow cast when each fibre snippet passes through the beam, while a number of detectors ensure accurate measurements are achieved at a rate of up to 100 fibres per second. The laser scan instrument measures not only the mean fibre diameter, but also additional measurements of diameter distribution, comfort factor, and fibre curvature. The amount of vegetable matter in any lot is determined by dissolving the dried wool sample in boiling caustic soda. In 3 minutes, the wool has dissolved, leaving behind the total alkali insoluble matter comprising vegetable matter and other non-wool components. This residue is rinsed in water to prevent further dissolving. The residue is then dried before being dissected into the various vegetable matter and non-vegetable matter components. Any material identified as seed and shive, burr or hardhead and twigs are classified as vegetable matter. The total vegetable matter percentage by weight is reported on the test certificate. Staple length and strength testing on greasy wool is performed in order to determine its likely processing performance. Research on both merino and crossbred wool has shown that the parameters measured during the length and strength test are critical to understanding how wool will react during carding, gilling and combing stages. The grab sample is laid out evenly over the belt of the mechanical tuft sampling machine. The MTS machine has 3 sets of pliers, which extract tufts of wool progressively from the grab sample as it passes through the machine. A minimum of 63 tufts are taken for measurement. The tufts are blown onto a gauze which is rolled up onto a reel for transport to the laboratory. At the laboratory, the gauze is unrolled from the reel at the staple preparation table. A team of 4 operators prepare a single staple from each tuft and place the staples into trays to ensure they sit straight for measurement. NZWTA uses Atlas machines to measure staple length and strength. The staples are tipped from the trays onto the belt of the Atlas. One by one, the staples pass through an LED array to determine the average staple length of the lot in millimeters. The coefficient of variation of staple length provides an indication of the amount of variation in length within the lot. Each staple is fed through the twin belts and clamped by the Atlas jaws 10 mm in from the tip of the staple. The second jaw grabs the base end of the staple. The jaws pull the staple until the staple ruptures, and the peak force required to rupture the staple is recorded in newtons. The 2 parts of the broken staple are weighed, and the linear density, or kilotex, of the staple is calculated from the length and the clean weight of the staple. The staple strength is reported as newtons per kilotex. The relative weights of the tip and base from the broken staple are used to determine the position along the staple in which it has ruptured. The percentage of staples that broke at the tip, middle and base ends are reported. The staple length, staple strength and position of break measurements are used along with fibre diameter and vegetable matter to predict the processing length of the wool.